function f such that the following requirements are met. F of 0 is equal to 3. The limit as x approaches 0 from the left of f of x is equal to 4. The limit as x approaches 0 from the right of f of x is equal to infinity. Oh, no, sorry, I just jumped lines. Let me erase that. Limit as x approaches 0 of f of x is equal to 2. Okay, and we have 4 more requirements here. We also have the limit as x approaches negative infinity of f of x is equal to negative infinity. The limit as x approaches 4 from the left of f of x is equal to negative infinity. The limit as x approaches 4 from the right of f of x is equal to positive infinity. And the limit as x approaches positive infinity of f of x is equal to 3. Okay, so we have quite a few requirements here for our particular function. All right, so we want to come up with a function f that satisfies all of these requirements. So when I think about this problem, the things that I want to first of all identify are things that I can write down right away. For example, if the requirement tells me that f of 0 equals 3, then I'm immediately going to write that one down because that one is a solid dot that I can draw on my paper. So f of 0 equals 3 tells me that when x equals 0, the y value of my function is equal to 3. And so I can check that off. So any sort of ordered pairs that I have, I want to write them down right away. Okay, so then I see that we've got some limits that involve x approaching 0, some limits where x is approaching 4, and then some limits as x approaches positive and negative infinity. So I'm going to look at these in groups. Let's look at the grouping where the limit is where x is approaching 0. So as x approaches 0 from the left, the y value of our function is approaching 4. So as I approach x equals 0 from the left, I know that I don't really know how the function is coming along, but eventually my y value is going to approach a y value of 4. Now, my limit does not tell me anything about what happens at x equal to 0. So this particular picture here is just saying, as x approaches 0 from the left, the y value is approaching 4, and to be safe, I'm going to put an empty hole up there, right at x equal to 0. So this guy is taken care of. Any questions about that? Okay. Now I'm going to approach 0 from the right-hand side. As we walk along the x-axis towards x equal to 0 from the right side, the y value of my function, as I look up toward my function, the y value is approaching a y value of 2. And so I want to make sure when I look up at my function, the y values are getting close to y equals 2. Now right at x equals 0, my limit tells me nothing, so I put an open circle there. So now these guys are all checked off. Okay. Next thing I'll deal with are these limits as x approaches 4. So we've got 1, 2, 3, 4. And as x approaches 4 from the left, the y value of my function is approaching negative infinity, getting very large downward. And so that's going to tell me that I'm going to have a vertical asymptote at x equal to 4. So I'm going to immediately draw that vertical asymptote in to help guide me. And as x approaches 4 from the left, the y value is approaching negative infinity, which means that my function is dropping down very fast. as x approaches 4 from the right-hand side. So I walk over here to the right-hand side of 4, and it tells me that that limit is equal to positive infinity. So as x approaches 4 from the right, the y value of my function is getting very, very, very large. So it looks something like this.
Can that come from below the x-axis?
Absolutely. So what I have drawn here, absolutely, I could have drawn something that started down here and went upwards. And if I wanted to, I could even throw in a couple of up and downs on my way in. As long as, once I really start approaching x equal to 4, my y values are getting larger and larger.
Don't you have to look at the other ones first?
Which ones?
Well, it says it's the limit is x goes to infinity at equals 3.
So thinking about this right here, so far all I've done is I have this picture here. So now let's take a look at these infinite limits. Okay? And so this says that as x gets really big, our y value of our function is approaching a y value of 3. So what I might do is I might give myself a little guideline here. Here's y equals 3. And so what I need to make sure is that this function that I've drawn here eventually ends up leveling off at a y value of 3. So even though I've already done my funky little curves in here, all I need to do is turn my curve and eventually have it level off.
So the vertical, it doesn't have to, you can actually go below it and be fine.
Absolutely, yep. I mean, I could even add something in here where this guy is going to go and pop up above and then come back down. As long as after a while my function eventually levels off near y equals 3, then I'm gold. But whatever happens in between 4 and infinity, anything can happen.
On that one, can the where it levels off be on top of the asymptote too?
Absolutely,
or?
yep. Yep. You can level off right on top of the asymptote, you can level off just below. It could even level off the way we saw that sine function where we did sine of x divided by x, and it continually oscillated up and down, it just dampened itself, so eventually almost looked like the y equals 3 line, so you can do that as well. Okay, other questions so far? Okay, so our very last piece is that, let's see, so we've checked off limit as x approaches infinity of f of x is equal to 3. And then the last one up here is as x approaches negative infinity, so as we walk far off to the left, the y value of our function is approaching negative infinity. So it means eventually it's heading down. Okay? Now what happens to it along the way, it doesn't matter as long as in the long term eventually it's going down. So I could have it pop up a hill, come down here, whatever, as long as eventually there it goes. So the rules are that there are tons and tons of functions that all can satisfy these 7 requirements, and as long as they satisfy those 7 requirements, and it's still a function, so you can still pass the vertical line test, then your function is probably a correct example.
So is there anything that would prevent this from being like a piecewise function?
No.
So you could have, I mean, they're continuous on a certain interval, as you've drawn them. But nothing in that tells us that that's really how they are.
No.
Right.
Nope.
Okay. All right.
This is really asking for
Right.
an
Right.
example.
Right.
And so, I mean, if you wanted to put a hole right here and put a dot right up here,
Right.
that doesn't change that these guys are all still met.
Should those open circles will remain open?
These two must remain open because we've required that f of 0 is equal to 3. And so these guys do need to be open. But if this requirement had not been here, if f of 0 equals 3 was not a requirement, then I wouldn't need this dot. And I could fill in either the top or the bottom or neither, or I could put a dot down here. So, wherever I want to put a dot is fine, or not have a dot at all. So I'll put the original requirement did include f of 0 equals 3. All right, questions or comments about that? You get to be creative with these graphs.